Okay, so I will take over from here.
Go ahead.
Yeah, so I will take over from here. Okay, thank you very much. So yeah, so my name is Zhang. You can call me Harry from Alibaba. I'm of course a CNCF ambassador. And today I will talk a little bit about the several things in the Kubernetes community, like GitOps, DSL, or configuration data language, and of course, application model. So the goal is how we can build something like developer-centric Kubernetes. Okay, let's get started. So who am I? Of course. So my team and my role in Alibaba is more like a platform builder or platform engineer. Though I also have many other names like Kubernetes engineer, platform service engineer, or sometimes be called as infrastructure operator. But only my colleagues know that I'm actually a YAML file engineer. So what do I build? I'm responsible for building various of platforms on top of Kubernetes to serve my users who are mostly application developers and operators in my company. They come from different business units. They actually serve their own customers. I mean, the customer for Alibaba directly, and we serve them. Okay, so you may be curious why I build such kind of platforms on top of Kubernetes, and why I build so many platforms on top of Kubernetes. Don't developers and operators in Alibaba, they use Kubernetes directly? So we hope so, actually, but the reality is not. The reason we need such platforms is because we need them to fill the gap between users' expectations and what Kubernetes provides. For example, first of all, the API and the primitives. What our users focus on are code, applications, and CI/CD pipelines. But if you look at our Kubernetes cluster, what it provides are workloads like deployment, stateful state, container level APIs like sidecar, pod, and even infrastructure details like network policy extract. The second issue is the levels of abstraction. For example, for application operators in our organization, they are working on policies like how to do auto scaling. They will define strategy like this. And for another example, how to do automatic rollout. They also define strategies to describe what kind of a route strategy they want to use. That is a job for our application operators. But what our Kubernetes provided to them, however, are, for example, Kubernetes service, ingress, Prometheus API, and Istio virtual service like that. So as Kubernetes expert like us, I mean, for me, it's straightforward to assemble the concept into something like a route strategy or auto scaling policy. But these primitives, however, really don't make any sense from our application operator's perspective. They don't even know what is Prometheus or Istio. So the last issue, which is actually the worst one, is the user interface. Platform builders, we think Kubernetes declarative API is very powerful and extensible. It's perfect. But our end users, I mean, developers and operators, definitely don't agree with that. They want to work with human readable interfaces like dashboard, like command line tool, or infrastructure as code. Writing Kubernetes YAML files, which is our normal life, however, for them is more like writing assembly language from developers' perspective, and no one wants to do that actually. And at the same time, we gradually noticed that building such kind of platform is not a silver bullet, because the biggest problem is that in order to serve our users better, in order to bring them with easier user experience, we tend to define our own platform level API. You can think of like a Cloud Foundry API or a Heroku API, which is more user-friendly and focused on higher level abstractions. But on the other hand, this kind of API will actually hide the extensibility of Kubernetes, because we basically lose the Kubernetes extensibility here because our users in that case can't access directly to Kubernetes. So they can't enjoy the unlimited capabilities provided by Kubernetes ecosystem. For example, Microsoft just released the open service mesh, correct? But it will need a very long time for our platform to support it, because our platform doesn't have such SMI API. We only support Istio for now. So this will require a huge refactoring effort in the platform layer. So this issue actually exists widely in the community. So a lot of people are asking this question, whether we should build a platform service at top of Kubernetes, whether should we hide Kubernetes APIs from our end users, something like that. That's why we also began to rethink this issue from another angle. Since Kubernetes is great for extensibility, right? And it also has a large number of capabilities in Kubernetes ecosystem, especially provided by CRDs and operators. So can we try to make Kubernetes itself more easier to use? I mean, build something like a developer-focused Kubernetes. That is to say, what we want to build is a Kubernetes that speaks higher level API, provide abstractions, which is user-friendly. And of course, still keep highly extensible. So it's essentially another form, or you can say it's a distribution of Kubernetes. So let's look at the higher level API at the start. It's essentially about building user-facing abstractions for your workloads and your operational capabilities like rollout, auto-scaling, and monitoring, right? There are various efforts in the community that could provide such kind of higher level abstractions on top of Kubernetes. For example, Knative and the Rancher Rail. I also list Heroku here because Heroku is a de facto standard or baseline for platform service world, which is a very good example if you want to compare it to Knative and Rail. So if we compare them from two dimensions, I mean, the learning curve and the level of abstraction, we can easily find out that the higher level the abstraction is, for example, like Heroku, the lower learning curve it is. That's why even today, everybody is still talking about the experience of Heroku is the best, right? And we need to bring this kind of experience to Kubernetes, to everywhere, or everybody's talking like that. Obviously, Heroku's developer-centric abstraction contributed a lot to its success. For example, it enables you to create a production-ready online service by one click, and only provided you with user-facing concepts like pipeline and application. You will never need to worry about infrastructure and low-level details at all if you are using Heroku. Well, compared to that, Rancher's Rail also provides a lot of higher-level abstractions by using its command line tool. But on the other hand, you will notice that it actually leaks a lot of Kubernetes details or infrastructure level details to end users. For example, secret config map, you need to care about the workload. You need to think about how to do manually traffic split. You need to manually manage the revisions like that. And when it comes to Knative, although it claims to be a serverless platform, but its abstraction is relatively lower level even than Rancher Rail. For example, you need to concern about pod template in Knative, which include many non-developer facing concepts like pod security policy, like volumes, a lot of things like that. Note that we're not talking about Cloud Run here. Cloud Run actually have much higher level abstraction than Knative. Knative is more like foundation below that. So of course, when it comes to Kubernetes itself, there are already many complaints about its super high learning curve, right? I will say it's actually natural, it's by design because Kubernetes is a platform for platform. It's designed for platform engineers like me to use. Just think about Linux kernel or Windows kernel here, right? It's by design. But on the other hand, we also notice that building such higher level abstraction always has compromise on extensibility. Let's still take these four projects here. For Heroku, the only way for you to extend this product is building Heroku add-ons by filling tons of restrictions and conventions defined by Heroku itself. It's essentially a closed system, right? So it can barely leverage the open source community, I mean the Kubernetes community or even wider community, because it's essentially vendor locking, and that is a big concern for the open source world. And for Rancher Rail, the same case, there are no even straightforward approach to support more workloads or capabilities in Rail. It's really hard unless you modify the code, refactor the project. I think it's also by design because Rail is a lightweighted wrapper on top of Kubernetes. So if you give it more flexibility to the users, it will essentially break its model and leak the abstraction. For Knative, however, you basically have more room to do customization. For example, it provides you with several extension points by design. And you can also write your own CRD the controller to extend the Knative as long as you don't break its fundamental model. That is how it works. Of course, for Kubernetes itself, it's probably, I think, the most extensible infrastructure system in the open source world because you can use CRD and operator or controller alone to model everything here. So you can see the difference here. The lower your abstraction is, the more extensibility you will have. And another drawback of building abstraction is if you want to do that on server side, I mean, you want to build abstractions inside Kubernetes by exposing CRDs to a user, you will really need to put a lot of engineering effort in this space. The reason is that abstraction actually have many forms. For example, you may want to combine a deployment and a service into one abstraction, which name it, for example, web service, right? So it will expose a external port by design. That is one kind of abstraction. We can call that composition. Or you may want to split, for example, Argo route into two simpler objects, which name it workload and a rollout. So you can do separate concerns here and let different persona. For example, developer will take care of the workload and the operator will take care of the route strategy. So they will have different objects and different APIs. It's separate concerns. Sometimes you want to do that. And we can call that decomposition. And there are also some cases that you want to transform, for example, deployment into a read-only and a simplified version, which name it is, for example, Knative revision. That is how they design today. You want to do transformation. It's also another kind of abstraction. So all of these efforts, even the simplest abstraction, for example, transformation, will require you to define CRD and implement controller in Kubernetes server side. You also need to think about the interoperability with other systems, with other objects. It's complicated. It should raise the bar very high for you to build abstraction. Not to mention the extra burden to maintain these controllers and CRDs. You are basically creating another Knative. Think about that. So basically, the difficulty of building abstractions is there. And besides that, we also notice some other issues like building abstractions will actually create more silos in your system or in your organization. This is because as a big company like Alibaba, like Microsoft, like Google, the requirements from our users, from our developers are highly diverse. For example, some applications in our organization are stateful workload. So we need to build them in stateful application platform with manual scaling policy, with canary route strategies. However, there are also many applications are stateless. They use deployment, for example, as workload. And vworks Flagger to do route, for example, and HPA for autoscaling, right? And there are also even some other applications that just prefer to go the serverless style. So we have to use Knative to serve them. See, also all of these platforms, they have unique requirements. They also share a lot in common. For example, all of these platforms may require the service like Let's Encrypt, right? But as platform builders, we have to implement this functionality in different forms again and again because every platform here speaks different API. So essentially, we're creating more fragmentations because we need to provide different abstractions to our developers. We're creating more silos and a more closed ecosystem and waste a lot of engineers' time here. That doesn't feel good. So I think we all agree that we want to build developer-centric Kubernetes now, right? We want to provide them abstractions. But obviously, the point is how. In the rest of the talk, I will try to introduce some useful tools that can help you to build such kind of abstractions and to build such kind of Kubernetes, which is end user facing. Maybe can create more possibilities for us to do this thing better. So the first thing I want to talk about is how we build the abstraction more easier. And the point here is we may want to consider the data configuration language, the DCL or DSL. So actually, if you revisit the 3 patterns of abstractions I mentioned before, you could find out that abstraction is basically about data manipulation, no matter it's decomposition, composition, or transformation. As why building abstraction should be should be handled by DSL or DCL, this kind of data configuration language, way easier than writing CRD and controllers, because DSL happens on client side. There's minimal maintenance effort for them, right? For example, I will highlight this Q here, the Q language here. Q is just perfect for you to define abstractions for configuration data. And Q don't want you to learn any programming language. Q don't want you to write a program to define abstraction. You don't need to do that. You don't need to write Python code or TypeScript code. You don't need to do that. Instead, it focuses only on data configuration to provide a superset of JSON language, of JSON. So it's essentially Q. So you can think of Q as just an advanced version of a JSON. And the actual value is, by using this kind of Q language, you can define types or schema for your data. That's how you define abstractions, actually. This is the main difference between Q and other DSLs, like, for example, CD Kubernetes from, or CDK from AWS, because CDK will require you to write program, and they encourage you to write your program to define abstraction, but Q do not work like that. Q itself is a configuration language. The only difference is Q allows you to define schema alongside with your data. And besides, Q defines, as I mentioned, Q defines schema and value in consistent grammar. So you will find its schema and your data you define follow the same pattern here. So it's basically like every time you play with Q, you will provide two things. The first is schema, the second is your data. And they all looks like a JSON. That's all. So it's very easy to learn. Although its documentation is not very good, I admit. But if you look at it in detail, it's very actually familiar with JSON language, whether for its schema or for its data. So you just define your schema and then define your data, and then you can use that to define any kind of abstraction you want. That's all. So for users, they can just interact with the abstraction data. That's why you can actually build your platform user interface based on this abstraction. And the client-side abstraction will handle the transformation from Q to the real raw Kubernetes data like deployment. But for user, they only need to define 3 fields in this case, in this example. Yeah, so this is, I think, either way or a better way to define abstraction instead of define a bunch of CRD and controller field Kubernetes cluster. The second tool is how we actually introduce a standard high-level API to users. And in this section, I will introduce the open application model, which is a project I personally also involved together with Microsoft. The core idea of OM is it enables you to define application-centric primitives, which are enforced by OM specification. And that's how you break the silos, as I mentioned, because all your platform now will speak same and standard API. For example, my first platform in this example is designed to run stateful workloads. So it will expose its own object to user, which named application configuration. And in that application configuration, it claims to deploy, for example, PostgreSQL operator. It's a stateful workload. And it also defines that manual scaling policy will be applied to this PostgreSQL operator. So we call that trait. So your workload and the trait are all contents in your application configuration. On the other hand, the second platform here, which is designed to run stateless workload, it will also expose a similar application configuration. The only difference here is that its workload will be changed to Kubernetes deployment, and its trait will be changed to Kubernetes HPA, horizontal pod autoscaler. So you can see difference here. Those two platforms expose similar API structure. The only difference is what kind of workload or what kind of trait it provides to users. And a similar pattern also applied to the third platform, which deploy Knative service. So it will claim Knative service as workload and use Knative autoscaler as a trait to scale the container. See, although the different characteristics in detail, these three platforms expose a unified API to end users. Such experience of consistency is the key to break silos in our organization. And due to now they share the same application model, all these platforms can now share a common pool of capabilities. And the platform builders can just pick what they want to assemble them into their own platform's API. It's just easy and neat. And all of these capabilities, they are Kubernetes CRD and operators or built-in Kubernetes APIs, nothing special. You don't need to reinvent any wheel here. And the last tool I want to highlight is GitOps. It's basically, in my opinion, the modern way to build a modularized CD system, continuous delivery system in Kubernetes. Today, the modern application delivery actually starts from developer writing code and trigger continuous integration process by pushing code to GitHub, for example. Then the CI system will generate Docker images as the artifacts of your application. And for development, for deployment for these artifacts for this image, we will write Kubernetes YAML files to define workload and operational configurations for your application. For example, the workload could be deployment, and the operational capability could be route strategy or scaling policy, right? And those YAML files normally stored in Git alongside with your application. So it will trigger GitOps workflow per every change in these files. For example, I changed the route strategy. And when this change reaches to Kubernetes, the controller like route controller will respond and perform the corresponding application delivery functionality. In this example, it will leverage Istio to do traffic shifting and use Prometheus to do automatic application revision promotion. So everything will work smoothly inside Kubernetes. And this GitOps application delivery workflow with Kubernetes and the controller pattern at its heart is very different from the traditional CI/CD pipeline. And the key point here is this system you can see here is highly modularized, because everything talking with Git as a standard interface. And the logics are just stable controllers and CRDs inside of Kubernetes. You can replace them at your will, right? And this kind of system is very easy to be integrated with any other system or any other external service. So this is why I say the GitOps workflow will make your system very extensible and bring the developer familiar experience by leveraging Git operations, right? Okay, so let's try to put them all together. So now we talk about, we use Q for building abstraction, and we use OM to organize your abstraction, which we named it as application model. And we will also use we will use GitOps for continuous delivery. So it seems like the developer-centric Kubernetes is coming up. Okay, let's see what the whole picture looks like. So first of all, in this POC is proof of concept. My version of developer-centric Kubernetes is based on GitOps workflow. But this time, what we stored in Git is not a Kubernetes YAML file. It's too complicated for our end users. Instead, we can define something which is super user-friendly. We call that application YAML file or application YAML. And this YAML file is based on Q language schema. And its structure is actually compliant or enforced by OM specification. So in this example, I just gave a very simple instance here. It's my application, and it's one component. A component is the concept of OM, and the workload for this component is deployment, right? And the fields you put here is actually abstraction defined by Q language or by Q schema. So you can define image, you can define environment. That is only concerns we expose to our users. Of course, we can change the Q schema at any time. Then our users can fill more fields in this section. That is the power of client-side abstraction. You don't need to write controllers. You don't need to refactor your code or redeploy your platform. You don't need to do that because everything here is client-side. And also it has a bunch of traits, including auto-scaling and rollout, expose. They are all CRDs over Kubernetes installed. And again, the fields user need to fill are still defined by Q schema. That's why this YAML file can be super simple, can be super developer focused or developer centric. That's the key. And any change on this YAML file will trigger the GitOps tools such as Flux or Argo CD to apply the changes to Kubernetes. And in that case, the Kubernetes, the own plugin for Kubernetes will then extract the information from the structure and use Q to generate the real Kubernetes API resource. And those Kubernetes API resource will drive the controllers, for example, route controller or auto-scaling controller to work. So in this sense, this system will provide developer-centric abstraction for our end users, but at the same time, it still keeps the extensibility of Kubernetes as a first-class citizen. And you can see here, even its abstraction layer is extensible because we can leverage the Q schema to do that in client-side. For example, if I want to enable open service mesh based, for example, I want to enable traffic split based on open service mesh, right, in this platform, I just need to install open service mesh in Kubernetes. And then I will use Q to define a abstraction for SMI traffic split CRD. And then I will define it as a trait in my YAML file because it's followed specification. So I can define trait and will. I can add more trait here. So everything will work. You can see here. The only thing that I need to do is install the capability, install the operator, and define abstraction by using Q, which is minimal effort. And then I can use structure to define the application YAML file here. So no single line of code is needed, essentially. Right, that is what I mentioned about how to build a easy abstraction, which is extensible, so we can build a developer-centric Kubernetes in that case. Okay, so this is just a proof of concept, and if anybody interested in that part, I'm very happy to collaborate with you to work on that in open source community, of course. And what's still missing here? If you want to move that kind of thing to a real-world solution. So I think the most important part is that today we basically don't have the add-on system to build platform. For example, how we register and discover Kubernetes API or CRD as a workload or trait. So we basically have a lot of CRDs in our Kubernetes cluster. So which CRD is the one I want to define in my application as part of my application? For example, rollouts, auto-scaling, or is still virtual service. We need to have a way to register them and discover them. And what's more important is, can we just automatically install missing controllers by given CRDs? It will actually make our platform more powerful and extensible in that case. So this is the first issue I don't have a solution for now. I think we can leverage Helm to do that if Helm can handle the dependency and package management as expected. The second thing is a modular command line tool or dashboard, because you can see here we emphasize extensibility very well. You can add more workload, you can add more trait to this platform, right? So when I register a new workload or trait in this system, how my command line tool or my dashboard immediately show up this new workload and trait, or just show up a new command line in my command line tool, right? This kind of thing will, if that can be implemented, this actually can improve the experience of our developers at a new stage, because its command line tool and dashboard become extensible. And the last thing is what will be a developer-centric pipeline looks like. I'm looking at Tecton, but Tecton itself is still very low level if you look at its primitives. But that reminds us, actually, you should have a way to build something with Tecton, right? To leverage Tecton capability to build something like a developer-facing pipeline, and you can deploy the pipeline into this kind of platform at ease, you can also leverage GitOps to do that. So I think this is also another field that we want to put some effort to looking at. Well, so this is the rest of things I'm also thinking of. Again, all of these efforts are early stage community effort, and I already noticed there's something already happened, something is still missing. So I will be very happy to talk with anyone and share the ideas regarding to building such kind of developer-centric Kubernetes. So basically, hope you enjoy the journey of building developer-facing or developer-centric Kubernetes. Okay, so this is the end of my session, and thank you very much for attending. Okay.
Thank you, Lee, for a great presentation. Do we have any questions at all? Okay, we have a question here. It says, I see a reference to stateless serverless container. Would you be able to elaborate a bit more on the container?
Yes, yes. So serverless container is actually a concept bring up by, for example, Knative and Cloud Run. So we can think of that. It's essentially a pod template of Kubernetes. It's a pod, but you just define it as a serverless container because, for example, in the Cloud Run and Fargate, and they will use the service pattern to deploy this container. For example, scale to 0, pay as you go. And this actually one of the key feature of the service pattern we all know about. So that is the service container. And so I'm basically talking about Cloud Run, Fargate, Microsoft, either ECI, and it's open source version, and of course Knative. And but Knative only provide actually part of that. For example, you can I don't think you can do pay-as-you-go pricing with Knative, but you can build on top of that. So this is a service container I'm talking about. It's an API which Knative and Cloud Run and Fargate provide to its end users, right?
Okay, do we have any other questions at all? Anyone at all? Okay, well, I would like to thank Lee again for a wonderful presentation. Oh, no, wait.
No problem.
Never mind. Thank you again, Lee, for a wonderful presentation. Thank you all for joining us today. The webinar recording and slides will be on the website later today at cncf.io/webinars. We look forward to seeing you again at a future CNCF webinar. Thank you again for participating. Have a wonderful day, everyone.
Thank you very much. Have a wonderful day.